Today, we're looking at adding an integer k to a number represented as an array of digits. The twist? This array form number could be incredibly large, far exceeding standard integer types. How do we perform this addition without overflowing our variables? Given an array number representing the digits of an integer and an integer k, our task is to return the array form of the sum of number and k. For instance, if number is 1200, representing 1200, and k is 34, the output should be an array representing 1234. The core challenge is handling numbers that might have hundreds or thousands of digits. A naive approach might be to convert the array number into a single large integer type, add k to it, and then convert the result back into an array of digits. Languages like CSharp offer big integer for this. While this works, it's inefficient. Converting the array to a big integer involves iterating through all digits, multiplying by powers of 10. Then converting back also requires repeated modulo and division operations. This repeated conversion and the overhead of big integer operations make it less optimal for very large inputs. It's big O of n time and big O of n space, but with significant constant factors. The optimal solution leverages the way we manually add numbers, digit by digit, from right to left, with a carryover. We'll iterate backwards through the number array, simultaneously processing digits from k. We start with an empty list for our result and a carry variable initialized to 0. In each step, we sum the current digit from number, if available, the current digit from k, by taking k modulo 10, and the carry. The last digit of this sum goes into our result list, and the remaining part becomes the new carry. We then move to the next digit of number and update k by integer division by 10. This continues until both number and k have been fully processed. If a final carry remains, we add it to the result list. Finally, reverse the result list to get the correct order. Let's trace this with number as 1200 and k is 34. We initialize an empty result list and carry to 0. First, I is 3, number 3 is 0. K is 34, so digit k is 4. Sum is 0 plus 4 plus 0, which is 4. Add 4 to result. Carry is 0. I becomes 2, k becomes 3. Next, I is 2, number 2 is 0. K is 3, so digit k is 3. Sum is 0 plus 3 plus 0, which is 3. Add 3 to result. Carry is 0. I becomes 1, k becomes 0. Now k is 0. The loop continues for remaining number digits. I is 1, number 1 is 2. Digit k is 0. Sum is 2 plus 0 plus 0, which is 2. Add 2 to result. Carry is 0. I becomes 0. Finally, I is 0, number 0 is 1. Digit k is 0. Sum is 1 plus 0 plus 0, which is 1. Add 1 to result. Carry is 0. I becomes minus 1. Both I and k are now 0, loop ends. No final carry. The result list is 4, 3, 2, 1. Reverse it. After reversing, our final result is 1, 2, 3, 4. This correctly represents the sum 1234, demonstrating how processing digit by digit handles potentially massive numbers without overflow issues. You'll spot this pattern whenever you need to perform arithmetic operations on numbers that are too large for standard integer types, especially when they're given as arrays of digits. It's a classic sign that a digit by digit carryover approach, mimicking manual arithmetic, will be the most robust solution. Time complexity is big O of n, where n is the length of number, as we iterate through its digits once. Space complexity is also big O of n for storing the result. This digit-by-digit addition is a fundamental technique. Try the next problem involving large number arithmetic, it often follows a similar pattern. Don't forget to subscribe for more concise DSA explainers.